Hey, I'm Jamie Carling, and I'm going to do my best to explain to you what 3D in science means. So, typically, if you go to the movie theater, you get 3D glasses to help you view things in a different way. So you can see the depth and have a new perspective. 3D science is really similar in that it creates a framework for you to see the main ways science is connected to the real world. So a lot of times we lose perspective and we get bogged down with the content. So I'm going to run you through an analogy that helps me kind of understand it for myself. So take a car, for example. If you can drive one car, you can pretty much drive most vehicles. So the end goal for, teaching with the three dimensions of science is to have scientific literacy for all your students. So for them to have scientific literacy, they need to know the parts and the functions of most things in the car. You don't want to go send them out in the car without, explaining they need gas in the car to actually travel very far, or about the oil changes, or about how to change a tire. You want your child to know these things before they go off driving on their own. Um, you need to know the basics of how a vehicle works. If you turn the steering wheel to the left, the car will go to the left. You got to use your blinkers. Um, these things you need your child to know. Okay, so this is similar to the three dimensions of science. So if you know the parts and the functions, that's like the cross-cutting concepts. There's patterns, there's cause and effect. If you kind of know how the vehicle works, that means you know the hows and whys, like what the radiator does, what the brakes do, that kind of stuff. And then the basics on how to drive would be like the content. So take earth science, for example, because that's what I teach. um, when you're teaching earth science, then let me move my head down for you. Um, if I were using the three dimensions, um, science and engineering practices would be the mechanics and why it works. The cross-cutting concepts, again, are the functions, the parts, the patterns. A lot of times you can answer cross-cutting concepts with yes, and this happens as well. Like students should be making a lot of connections between disciplines and between topics in class by seeing these similarities over and over and over. The disciplinary core ideas are ways to apply it to make it work. So it's really your vehicle. So you can drive anything. It's just one way to apply it. So it's just one type of car, but it works with everything. So how does this work? Well, you pull one topic from each part. So for example, a science and engineering practice, you would pull one aspect of that. So for example, analyze and interpret data. You would pull one aspect of cross-cutting concepts. So for example, patterns. And then you would apply it to earth science. And whenever you figure out, your three core ideas, then you want to ask yourself at the very beginning, what do you want them to learn? So what exactly is that topic? And then how are you going to measure it? What are they going to be producing that identifies, yes, they learned that? So you always want to go in with those three things. And then you should also be recognizing that this framework is really familiar. So if you've taught in the state of Utah, we have intended learning outcomes, so we call those ILOs, and all of these, the vast majority, are located, every single science and engineering practice or cross-cutting concept or core idea is located right there in your standards previously. They have just, chunked them in identifying pieces so that we actually teach with them, not applying them as an afterthought to our lesson plans. So, for example, Here's another earth science example. So the science and engineering practice is to develop a model of the carbon cycle. So I would have my students develop a model, and in that model, they would have to show how energy and matter flows in that model. So in that system that we're learning about. So this, you can see how inside of that triangle is what I want them to learn. I want them to learn about the carbon cycle. That is my earth science standard. How am I going to measure it? Well, I'm measuring it because they produced a model, and in that model, they used arrows and diagrams and words to really show how energy and matter flowed through the ecosystem throughout the carbon cycle. So I should be able to identify photosynthesis, you know, and emissions and carbon sinks and carbon sources and so on. So earth science, I can teach scientific literacy in my class. What students learn in my class should be transferable to any discipline, any discipline in science and outside of science. So for example, looking for evidence and planning investigations, this is something they can use throughout their entire life. So if they're a police officer, very applicable. If they're a mom, oh, what did my child eat that made them develop this rash? They need evidence. Okay. I'm teaching them patterns. I'm showing them how to recognize cause and effects. This stuff happens all the time in the real world. Think of your own life for today. How many times did you use cause and effect? I did this and then this happened. Or I need to come up with evidence about this topic so I can win my argument. Okay, so back to my car analogy, no matter what vehicle you're driving, you can always teach the 3 dimensions of science with it. It helps you stay more focused and helps your content have more meaning and be more applicable. And just like, a lot of times people think, it's changing again, change is bad, and I don't want my standards to change. And I just want you guys to all remember, you know, the cars themselves have evolved, and we like our cars today. We don't want to be driving these old clunker cars. They're not as economical, they don't hold up as well, and so on. So be aware that everything is changing, and we need to change with it so that we can empower our students more. So as teachers, we need to help them see and connect all the pieces to make learning more applicable to them today.